Hi guys, so I have another topic to discuss with you today, and that is indices. So today's class, we're going to discuss what indices is, and we're also going to talk about the laws of indices and the application of the laws of indices. But before we proceed, what is indices? Indices is the plural of index. An index itself is the power or the exponent raised to a number or variable. So index is a way of expressing a number in an easier manner. That is, if I have an index notation of a raised to the power of n, my a is called the base, while my n is my index. And this an expression called index notation. Algebraically, if I have a times a times a times a, I can express this as a raised to the power of 4. Mathematically, if I also have 3 times 3 times 3 times 3, this can be expressed as 3 raised to the power of 4. All these expressions are called index notation. Now let's talk about the laws of indices one after the other. So the first law we're going to discuss in today's class is called multiplication law, which is also known as the addition law of indices. The first law, which is multiplication law of indices, says that when the numbers with equal bases are being multiplied, their power, the index, are to be added. That is, if I have a raised to the power of m times a raised to the power of n, this implies that a, since they have common basis, which is the a, raised to the power of m plus n. So the index are to be added. Mathematically, if I have 3 raised to the power of 2 times 3 raised to the power of 5, this implies that 3 will be raised to the power of 2 plus 5, and this will be equals to 3 raised to the power of 7. That's what it means. In other words, if you have 3 times 3, then you also have another times 3 times 3 times 3 times 3. If we add up all the 3's that we have here, let's count 1, 2, 3, 4, 5, 6, 7, which simply means 3 raised to the power of 7. So indices is a way of simplifying a number. It's a method of shortening the product of what? Of number. So let's discuss the second law of indices, which is the division law. It's also known as the quotient law of indices. The division law, which is also known as the quotient law of indices, says that when dividing numbers with equal bases, the power of the divisor is subtracted from that of the dividing. That is, if I have a raised to the power of m divided by a raised to the power of n, I can re-express this as a raised to the power of m divided by a raised to the power of n. Mathematically, I will express this as a raised to the power of m minus n, since the base are the same. So we're going to subtract the index of the divisor from the dividend. Now, mathematically, if I have 2 raised to the power of 9 divided by 2 raised to the power of 6, this implies that 2 will occur 9 times. We multiply 2 9 times. Let's go. 2 times 2 times 2 times 2 times 2 times 2 times 2, 7 2 times 2 times 2. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. Divided by another 2 divided by another 2. 2 times 2 times 2 times 2 times 2 times 2 and 2, 3, 4, 5, 6. Now, what this implies is that we have to cancel out what? 2. Let's cancel all these 2 and see the 2 we are having left. Cancel out 2 here. Cancel out another 2 here. Another 2. So that means we are left with how many 2? Just 3, 2. That means we will be having 2 times 2, 2 times 2 times 2. And this implies that 2 times 2 for 4 times 2 is what is 8. And this expression here can be re-expressed as 2 raised to the power of 3. That is, this expression is an index expression. So 2 raised to the power of 3 is an index expression, which is the simplest way of shortening the product of numbers of equal factor or numbers that are the same. So let's discuss the third law. What does the third law say? The third law of indices, which is the power law, says that if a number which is raised to a certain power is again raised to another power, the two powers are to be multiplied together. That is, if I have a raised to the power of m, we close the bracket, raised to the power of n. So this implies that your a, which is your base, will be raised to the power of m times n. That's what it means. That's what the third law says. The third law says if a number which is raised to a certain power is again raised to another power, the two powers are to be multiplied together. So that's what we've just done here. So mathematically, if you have 4 raised to the power of 2, close the bracket, raised to the power of what? Of 3. This implies that your 4 will be raised to the power of 2 times 3. And that will give you what? 4 raised to the power of what? Of 6. That is your index notation for the third law. Now let's move to the fourth law. Now the fourth law of indices we're going to discuss now is the zero index law. The zero index law says when any number or quantity is raised to the power of 0, then the result is 1. That is, if you have a raised to the power of n divided by a raised to the power of n. This implies that a will be raised to the power of n minus 1. We recall from our second law of what? Indices, which is the division law. So this will implies a raised to the power of 0. And anything raised to the power of 0 will always give you what? Always give you 1. Mathematically, if we have 4 raised to the power of 2 divided by 4 raised to the power of 2, 4 will be raised to the power of 2 minus 2, and that will give us 4 raised to the power of 0, and that will give us 1. That's what the fourth law of indices, which is the zero index law, says. Now let's move to the fifth law. The fifth law of indices, which is the negative index law, says that a number raised to a negative index is equal to the reciprocal raised to the same positive index. He said a number raised to a negative index is equal to the reciprocal raised to the same positive index. That is, if we have a raised to the power of minus n will be equals to 1 over a raised to the power of n, which is the reciprocal of the same number given to us. Mathematically, if I have 3 raised to the power of minus 2, I can re-express this as 1 over 3 raised to the power of 2. And that will give me what? 1 over 9. That will be my final answer. So now let's move to the sixth law of indices. The sixth law of indices is the root power law. The root power law says when you have a raised to the power of 1 over n raised to the power of 1 over n. This implies that your a will be what? N root. Your a will be n root, close the bracket, raised to the power of 1. Your a will be n root, close the bracket, raised to the power of 1. Similarly, if I have a raised to the power of m over n, I can re-express this as a n root, open bracket, close the bracket, raised to the power of what? Of m, of which m could be any variable. So as we proceed in the lesson of indices, we're going to be applying this law one after the other. The seventh law of indices is the product power law. And the product power law says when the product of different factors are raised to a certain power, the power is distributed over each factor in the bracket. For instance, if we have open bracket AB close bracket raised to the power of n, this implies that your index n will be multiplied through by the factors in the bracket. That is, we're going to be having a raised to the power of n times b raised to the power of n. Mathematically, if I have 4 in bracket x, y raised to the power of 2, this simply means we distribute the index outside here, we multiply the index all through by the factors given in the bracket. We have 4 raised to the power of 2 times x raised to the power of 2 times y raised to the power of 2. So 4 raised to the power of 2 simply means 4 times 4, and that will give us 16. So our final answer is going to be 16 times x squared times y squared. And we can re-express this as 16 x squared y squared. That will be our final answer. So now, let's apply this law in solving problems in indices.